Last time we started this section on real numbers, and we had taken a look at some number line graphing, and we had looked at ordering of values, like less than and greater than kind of symbols. And the last thing I wanted to cover in this section is a little bit about radicals. So this is certainly not, an in-depth discussion, but just a reminder of some things that you've seen before. So we're going to start first specifically talking about square roots. A square root is one of two equal factors of a number. So if you'll remember, square roots look like this. Just a little bit of a reminder of vocabulary. If there's a number here, that number is called the index. If you don't see a number there, then you have indeed the index of 2. There's an understood 2 here if there's not a number there. We're only talking about that today. We're not talking about any other numbers there. So all of ours are square roots because there's an index of 2. This symbol here is called a radical. And any value underneath is called a radicand. So if you're looking at the example below, 64 would be called the radicand. And the index would be a 2 because you don't see any other number written here. I'm not going to quiz you on this vocabulary, but just so that if I say the word, you're not like, what's she talking about? I want to make sure that you're aware of just some basic kind of vocabulary for these symbols.
What did you say it's called when it's inside?
Radicand. And it's spelled up here like this. It's really small. I need to write just a little bit bigger. My apologies. How's that? Isn't that a nice feature? Super cool, right? Yeah, so, yeah, this is the radical. And index. Okay, so very good. When we talk about square roots, we're usually, at least at this stage in the game, talking about what we call principal square roots. So principal square roots are the non-negative square roots of a number. So like for example, there are two different pairs of numbers that when you multiply them together, the same number twice, you get 64. What is one way to break 64 down into two equal factors? 8 and 8. Technically, what's another way to break it down? -8 and -8. And they're actually both the square root of 64. All right? They really are. However, we're going to be talking about the principal square roots, which means we're not talking about the negative ones. We're talking about the non-negative ones. Okay, so it's the ones you would have naturally thought of if I hadn't said, well, technically there's another option, right? It was the one you were thinking. When you saw a square root of 64, you probably knew the answer pretty much right away. What's the square root of 64 when you normally see it written that way? It's 8. And that is the value that we're looking for when we talk about principal square roots. That's the ones we're going to be looking at. It's principal square roots. So, not all values have perfect squares or perfect square roots. So we call a number a perfect square when it's a square root that it's a rational number. And most of the ones we're going to be looking at are even more specifically whole numbers. So, for example, a perfect square would be the number 25 or the number 81. And the reason is because what is the square root of 25? 5. And what is the square root of 81? 9. They're rational numbers. And even better, they're whole numbers. A non-example, something that's not a perfect square, would be something like 52 or 30. If I try to find those values, they're not going to actually give me rational numbers. Your calculator will, by all means, turn it into a decimal approximation, but it will just be an approximation. It will not actually be a terminating decimal. Okay? So what we would like to know, without using our calculator a lot of times, is what is it approximately? You know, what kind of an approximation would I get? If I look at 52, or if I look at 30, and I wanted the square root, and I'm not allowed to use my calculator because my math teacher's being mean and won't let me, right? And I just needed to get an approximation. I'm building something. You realize that radicals show up in building things all the time? Hypotenuse of triangles are most of the time irrational radicals. And if you just wanted to know the approximate length, you could do it. And it's really not that difficult. So let's take a look at how. We're going to do an example of the number square root of 20. And then I'm going to take a look back at the 52 and the 30 that I just mentioned above. Okay? So square root of 20. Well, I would like for you to think of two numbers that are close to 20, one smaller and one bigger, that are perfect square roots. Let's go with smaller first. What is a number smaller than 20 that has a perfect square root? 4, but not 4, 16. Okay, so the square root of 16 is the value 4, right? Yeah, the square root of 16 is really close to 20, agreed? And it's perfect. If you take the square root, you get a whole number. It's fantastic. We want to do the same thing slightly above 20. What's a number bigger than 20 that has the same property? 25. So if I were to take the square root of 25, what would I get? 5. So what that tells you is that the square root of 20 is somewhere between 4 and 5. That's really what it tells you. So it says find two consecutive whole numbers that square root of 20 lies between. And the answer is between 4 and 5. So just for fun, I don't even have this in my notes, but I think we can handle it. Let's try the 52 and the 30 that I just made up. Okay? 52. I need a number below 52, not drastically below. Like, I don't want to go down to 16. 16 is not close to 52, okay? Close to 52 that has a perfect square root. 49. What is the square root of 49? 7. And what's a number bigger than 52 that has a perfect root? It's a little further away this time, but it's the closest one. 64, right? And the square root of 64 is 8. So the square root of 52 is somewhere between 7 and 8. This right here that you're seeing me write, this is the stuff I would expect to see on your paper. If you just tell me 7 and 8, that's not really telling me that you didn't have your calculator sitting there to confirm that you were correct. I'd like to know, were you able to sort of reason that out? Mathematics is really not about numbers. I know people think it is because that's what they've been ingraining with you for the last 12 years. But it's really about a thinking and a reasoning process. Do you guys see that? It really is. And so that's what I'd like to see, is what you're thinking about. Let's try 30. Okay, so I'm not going to say anything. I just want you to do it. A number slightly below, a number slightly above. Writing down all the work that I've modeled in the last two problems. And when you're finished, turn to a neighbor and ask them if they got what you did. Show them your paper, check their paper, confirm that you guys have the same thing. What number below 30 did you use? 25. Because the square root of 25 is what? 5. What number above 30 did you use? 36, because the square root of 36 is 6. And so your answer is that it's between 5 and 6. Okay, everybody good with that? Fantastic.